All right, guys, let's do some examples for graphing transformed tangent and cotangent functions. So we have this first example here, y equals 3 tangent of x. And so we kind of have the same idea of doing it in steps like we did on the last video with sine and cosine. And so first, let's identify what each of our transformations, A, B, C, D, will be, and the period in increments. So looking at this function, y equals 3x, well, that tells us that there's a 3 being multiplied out in front, and that is the a. There's nothing being multiplied directly to x, and so that means that, that hidden number being multiplied would just be 1. And then we don't see anything being added or subtracted at all, so both C and D will be 0. All right, well, the period is 180 degrees, or in other words, pi divided by b. I see my increments are in degrees here, so I'm going to leave it as 180. Well, 180 divided by b just equals 180 divided by 1, so just 180. And then for the increments, that would be the period, so 180 degrees divided by 4. So we have every increment will be 45 degrees. Even just knowing that fact that my increments are 45 degrees apart, I'm going to go ahead and add in all my 45-degree increments. Okay, well, step 2, it says label the center line with the value of D. Well, D is 0, and so that means that center line, that midline, did not change at all. And so it's going to remain at 0. Whether you call it the middle line or the center line does not matter. Okay, and then use the amplitude, so A, to find the max and min, and I should say maximum and minimum of like the points we're going to plot. Because technically the graph does keep going after those top and bottom points. Okay, so A is 3, and so that tells us that, whoopsies, 1, 2, 3, -1, -2, -3. So that the top points will be at +3, and the bottom point is going to be at -3. Okay, and then it says find the period, so step 3, find the period, and then the size of the increments. Well, oops, I already did that. Step 4, label the first tick mark using C. Well, C is 0. That means that I did not move left or right at all from my, my first point. The first point, think y-intercept. So the y-intercept for tangent is at 0, so it is just going to remain at 0. Okay, and then label at least 4 more points at equal distances using those increments, and then label them starting from this initial point here that we just plotted on the y-intercept. And you can draw more than one period, definitely do draw, I would draw as many periods that will fit on your graph. All right, and so from this middle point here that I have drawn, I am going to plot my next points 45 degrees away. I know tangent, the parent function of tangent, looking here, the point to the left is down below, and the point to the right is above the middle point. So I want to fit that pattern since I didn't have any reflections or anything. And so 45 degrees to the left of this point will be here. Oops, and that was a mistake because we have a new amplitude. So I need to actually plot that point on this blue dashed line. So that's what amplitude helps us with. It helps us, when we do plot that point, however many, or whatever the increment is away, it helps us figure out how, in the y direction, how far away it is from the middle point. And then 45 degrees in the positive would be up. Since I didn't have any left or right movement, my asymptotes will be in the same spot that they were for the parent function. So I have an asymptote at -90 and +90 for tangent, and then at positive and negative 270. Okay, so I'm going to continue plotting those points. So now in my next section between asymptotes, same thing. I'm going to plot halfway between these asymptotes on the middle line. And then evenly spaced, so 45 degrees in either direction from this point at 180. I have a point below on that -3 and above. Okay, then my one to the left of the middle asymptotes, I have again, plot your middle point on the middle line, and then the point to the left down below, and the point to the right up above. I'm plotting everything 45 degrees away from each other, but also notice I'm realizing that, hey, that middle point is gonna be on the middle line, smack dab in the middle of my asymptotes. Okay, so everything should be evenly spaced. And then lastly, I have a couple more points on either end. Okay, and now I can draw my graphs. So starting from the middle, that was horrible. Looks like a linear line. Come on. All right, and there we go, our first example. Okay, and so if you just labeling a couple more things. So we already labeled the midline, and then the distance between the midline and the top point and bottom point would be A. The C is the left and right movement. That was 0, so we stayed here at 0 for the y-intercept, and every point is 45 degrees away from the next. All right, guys. Let's go ahead and do another example. Example 2 is a little more actually difficult in my opinion than example 3, so I'm going to do example 3 first. I'm actually going to save example 2 for in class because I want to do one of these cotangent ones. Okay, so same thing as before, I'd follow the steps. So first let's figure out what A, B, C, and D are. So notice we have again a 3 being multiplied in front. So that will be A. Notice there's nothing being multiplied directly to X outside those parentheses, so that's going to stay 1. And then we do now have something being added inside the parentheses. Remember for the for C on the transformations, it's X minus C. Okay, so looking at this transformed functions, it's minus C. So remember, think opposite. So if it's plus 45, C has to be negative 45 degrees. So that will shift our y-intercept. We're not adding or subtracting anything at the end, so that is 0. For the period, we have 180 degrees. I see my increments are in degrees, so I'm in degree mode here. 180 divided by B, so divided by 1 is just 180. And then for my increments, 180 divided by 4, is again 45 degrees. Okay, and so now let's start drawing some stuff. My midline did not change. That is still at 0. Okay, using then my amplitude, I will, I know that I'll have my highest point that I'm going to plot, not necessarily the highest of the graph, but highest point I'll plot will be up here at 3. The lowest will be here at -3. All right, and then I know that my graph has moved either left or right. Well, if C is -45 degrees, that means that initial point, my y-intercept, has moved to the left 45 degrees. So let's write that. So I'm circling that. So the y-intercept has moved left 45 degrees. Okay, and so I'm gonna draw in my 45-degree increments like I've been doing. Just halfway between every tick mark. So my first point, I'm not gonna put it on the origin like I did before. Instead, I'm gonna put it at -45 degrees. All right, and so what that does is it shifts everything to the left 45 degrees. So before we had, for our parent functions, asymptotes at negative and positive 90 and -270 and positive 270. So all of those asymptotes are gonna move to the left 45 degrees. So I'll go ahead and draw those. So to the, so we had one at positive 90. So when I go from positive 90 to the left 45 degrees, that's here at 45 degrees. I had one at -90, so go to the left 45 degrees of that. -270, go 45 degrees to the left of that. And positive 270, same thing, 45 degrees to the left of that. All right, and now I can go ahead and plot the rest of my points. Again, I know that I'm gonna have all of these points. They're gonna be 45 degrees away from the next point, but they're also all gonna be evenly spaced between these asymptotes, meaning halfway between this point I just plotted here and my asymptote to the left of it would be at this 90, or in other words, 45 degrees away. So I'm gonna plot a point, whoopsies. I put it up top. Tangent does not go down as we move to the right, it goes up. I should have put it down here. All right, and then 45 degrees to the right of this would be on the axis. Okay, and then my next set of asymptotes, I'm gonna put a point right smack dab in the middle, and then 45 degrees away from that point, I'm at the bottom, and then 45 degrees in the positive direction, I'm at the top. So I'm just gonna keep doing this pattern. Okay. Alrighty. Okay, so now when I go to connect these, same as always. Sometimes they just look a little better when I just break it into 2 parts. Nope, well, kind of. Okay. All right, and so there we go. All right, let's do one more example. We're gonna do cotangent. So going on the next page here, I see that I'll do example 4. So I see that first I have a number being multiplied out in front. That is my A value. And I have a number being multiplied directly to X. So that's my B value. Nothing's being added or subtracted, so C and D remain 0. All right, for the period, that is, in this case, we're in radians. So instead of 180, I'm using pi. Well, pi divided by B would be pi divided by 1/2. Well, instead of dividing by a fraction, let's multiply by its reciprocal. And so for the period, we get 2 pi. Then for the increments, well, 2 pi divided by 4, simplify that, that's pi over 2. So every increment will be pi over 2, which is the same as 90 degrees away. All right, so let's label the midline. I did not add or subtract anything for D, so it's going to stay here at 0. A determines where I'm going to plot the top and the bottom point, so that is 2. So up here at 2, I'm going to draw where my top point will be and my bottom point will be. And then asymptotes. So for cotangent, if you look at the parent function, we had asymptotes at 0. So remember, we did not have a y-intercept. Instead, it was an asymptote. So at 0, and then you would go 180 degrees in either direction. Again, notice that the period is 180 degrees. That's the distance between two asymptotes for both tangent and cotangent, unless we have a transformation that changes the period. Okay, and which in this case we do. All right, so since we didn't move left or right at all, I know that that asymptote that was on the y-axis will stay there. So in the last example with tangent, we knew that the starting point was the y-intercept, and we had to shift that because of our c value. So for cotangent, the starting point is the asymptote on the y-axis, and if c is not 0, we'd have to shift it, but in this case, it's 0. And now let's put the other two asymptotes down. Well, my period has changed to 2 pi. So my next asymptote will be 2 pi away in either direction. Alrighty. And then now I can go ahead and start plotting some points. And so I know that I'm definitely going to have a point in the my middle point's going to be on the midline, directly smack dab in the middle of these two asymptotes. And then for cotangent, we don't go up as we move from left to right, we go down. So now the point to the left of my middle point will be above. Okay, and notice I plotted it halfway between the middle point and the asymptote. And then my next point will be halfway between that middle point and my asymptote on the right. And notice that every time I'm plotting a point, this distance here is indeed pi over 2. Okay, so even just looking between, pi over 2 and pi here, you can see that's an increment of pi over 2. Okay, and then now I'm going to draw my two lines. Let me just erase what I put there. And so my two lines, again, I'm starting at the top now and going down for cotangent. And there we have our graphs, our graph. All right, guys, that's going to be all the examples we do in the video. You guys have a great rest of your day. Don't forget your short homework after this.